Hello and welcome to Bits and Pieces lecture number 3, Minecraft Bit Magic. So in previous lectures we've been taking a look at how we work with binary and how we work with individual bits with bit operators and bit shifts and so on. And now we're going to take a look at how we can apply that in bigger examples, and we're going to use that in Minecraft so we can see a bit of how we can use it there. Of course, we won't be able to take a look on everything that you can do in Minecraft with bits. Of course, that would be like saying, all right, let's take a look on whatever we can do with whatever integers and so on. So obviously, that's not going to be the case. We're going to take a look at one example with a block and one example with an item, and then we'll see an example with some colors in the end. So it's going to be an example there of what we can do with all of these things. So let's get started. So I'm going to start with creating that block that I was talking about. So here we go, new class, and then I'm just going to create, and I'm going to call it block color, like so. And I've already prepared some textures for these things, so let's take a look on those. So if I head into here, I'm currently in it's these bits there, that's the MCP folder. And then I'm just going to head into assets here, example, textures, like so, and then we have here in blocks. So I have all the old stuff from other courses, but I also have color blue front, color blue side, green front, green side, red, red, white, and white. So I have one for each of 4 colors. So we have blue, green, red, and white, and then we have one front version and one side version. And that's pretty much for right now. And what we want to do, well, what I want to do here is store in the metadata which color this block has, one of 4, but we also want to store which side is going to face the front, well, where we're going to put the front texture, because that's going to be used later on. I only want to work with the 4 real sides, not top and bottom. They are sides of the block, but, well, not on the sides, I guess you can call them. So that's the idea of this block here. Okay, so first of all I need to add like some of these stuff, like block, color, like so. This is the constructor, and we need the ID, of course, like that. So basic stuff. We'll get to the bit operators in just a second or two. Super here, and let's send it the ID. We can work with, I don't know, the material of iron. That's totally fine. Set step sounds, step sound like that. Let's use the metal, so sound metal like that. We got some basic setup here. Set hardness like that. 1F will do fine, and then a creative tab as well. Maybe spell that properly. So set creative tab. Creative tabs dot tab. I'm going to put it in redstone. This is going to be something that works with redstone in the end. It's going to take quite a long time before I implement the redstone feature there, but I'm going to put it there for now because that's where it's going to be in the end. So that's pretty much why I put it in redstone there. I also want to set its unlocalized names and do things like that. So to do so, I'm going to head over to block info here and define all of those pieces of information that we're going to use. And the ones I do have are the following. I'm just going to paste them all here. Okay, so what we have is the colors ID, the ID there, the key. So as you can see, I'm calling it a color deployer. That's exactly what I'm having it for. Color default, color unlocalized name, color name, and some of these different textures. So what we have is the main texture name, which is color. Then we have the 4 different colors of that. So we have white, red, green, and blue, and then we have so the color here is the prefix. Here we have the main part, I guess, and here we have the suffix, so it's either a front or a side, like that. So what I'm going to do is basically refer to these ones depending on which textures I want. Okay, so unlocalized name, that's an easy one. Set unlocalized name, and then just block info dot color unlocalized name like that. There we go. Okay, so far we haven't done anything with bit operators, but they will come in just a second. But before we want to do that, I just want to load the icons. Then we can start working properly. So let's load all of these icons. We'll register them all like so. And I'm going to have 2 arrays. You could use 1 array if you wanted to, but I'm going to have 2 to make it clear what's going on. One for the front icons, and one for the side ones. like that. And now I'm just going to load them there depending on the different colors. We want one front for each color and one side for each color, obviously, and that's exactly why I have them as arrays. So then we can do front icons equals new icon, and the length here is obviously the same length as the ones we have as the textures, so color, texture colors like that. So that's just the length that is going to define how many fronts that we do have. For int I equals 0, I is less than, that should be icon, sorry, less than front icons dot length, like that. So we just loop through those icons, and then it's just a matter of registering these. How do we do that? Well, front icons at the index there, register icon. Right. Block info, texture location, add a column there. Then add the prefix, which is just the color texture. Then we add the main part, which is block info dot color. What's it called? Color texture colors, like so. And then finally, what we want to add is the suffix, which is block info dot color texture front. So these are the front ones, like so. So that's just going to load the 4 different front icons like that. And Eclipse wanted to import that in a wrong way, but we want the icon one, like so, from Minecraft, like that. And then we can just do the exact same thing for the side as well. So I'm just going to copy this part, use side, if I can spell that properly. There we go, side icons, add that there, use that there, and the only difference in the end when we register them is of course that we use the side suffix there instead. Okay, there we go. Now we have prepared everything that we have to do before we can start working with the bits and so on. So what I want to do is return the correct icon here. And how do we do that? Well, we need to store that somewhere, which icon to use. And what we do get is the side and the metadata. And the metadata, we've used that before as being from well, you can say from 0 to 15. But if we take a closer look on what that is in binary, we will understand why we can have it from 0 to 15. So let's add 0b there to just define that. 0, 0, 0, 0 to, come on, select that, 0b, 1, 1, 1, 1. So what we actually do have is 4 bits. And the reason why you usually go from 0 to 15 is because, well, if you just represent that in base 10, then we go from 0 to 15 like that, and that's exactly how much we can store. So there's no, this bit won't, well, that's not a signed bit, so 0 to 15 like that. But there's nothing forcing us to actually use these 4 bits as just the base 10 number right away. So that's not what we're going to do this time. This time we're going to use them differently. So what I want to do is store, like I said, the color and which side is the front side. And I can do both of those in the metadata. I'm going to use 2 bits for each of them. So first of all, we can get the color here. Int color equals meta and 0b0011, like that. So I'm just going to use these 2 bits here. And the reason why I set 2 zeros there in the start, of course we don't need to add leading zeros, but it sort of indicates that, alright, we have 4 bits in total in the metadata, so we can just see easily that, alright, we use these 2, we don't use these 2. Of course we wouldn't need them, we could put it like that. It doesn't really matter. I'm going to use it like that, so I'm going to specify 4 bits so we can easily see that. Okay, so the color is stored there, fine by me. But what we want to do now is, if it's the top side and the bottom side, I don't want to be able to allow the user to set those to the front. It wouldn't really make sense. That would be like having a furnace and then you would put it down and you have the front facing upwards. So you know, the front there which is changing if you're using it would be towards the top or towards the bottom. I don't want that. So if it's the bottom side, side equals 0, or if it's the top side, side equals 1, then I want to return side icons, like so. So we want to return the side here, but which side do we want to do? Well, use rather, which side do we want to return? Well, it's of course the one depending on the color, because when we load these, what we do is, well, we don't do it properly. We need to refer to the index, of course. like that. Sorry about that. So we get the correct color here when we load it, and then we can just refer to that by having the color stored in the metadata and using that mask there to get it out of the metadata and just return the correct side icon like so. But otherwise, what do we want to do otherwise? Well, if it's actually a side of this block, then we will have a side value of 2, 3, 4, or 5. So we have those 4 sides there as numbers 2, 3, 4, or 5. That's not really what I want. I want to decrease that by 2. Why do I want to do that? Well, then we get 0, 1, 2, and 3, and we can fit that into 2 bits. Do we have 2 bits left? Of course we do. So just because we don't have to be able to set the top and the bottom side, we can store that in 2 bits, and we have already used 2 bits for the colors, and therefore we have 2 bits left. So we are going to use all 4 bits here that we're using, well, that the metadata has, and then we can calculate which side is the front one. Okay, it's fairly simple. We do meta and this mask instead. So we just use the 2 other bits. So here we use the 2 least significant ones. Here we use the 2 most significant ones. So these 2 bits here are used for the colors, whereas these guys are used for the side there. But we're not done, because we will get a result that is 2 bits too far up, if you want to say it like that. Well, they are in the wrong position. If we want to get a side, we don't want to get it as like 4, 5, and things like that. Up here, well, you can't get 5, but 4 and 12 and 8 and so on. We don't want that. We want to move these down by 2 like that. So yes, because these are located at this position here, we want to get it with the mask and then move them down by shifting them to the right like that. Okay, so now we actually do have the side here that is the current front side, and we also do have the side here as 0, 1, 2, or 3, and therefore we can just compare these two to tell the code if this side here that we sent along is actually going to be represented as the front side or not. Return front side equals side. So if these two are the same, then what we want to do is return the front icons of that specific color that we've also received from the metadata like so. If that's not the case, then we want to return the side icons at that specific color like so. So there we go. What we have here in the this block is that we use the metadata, but we don't use the values to go from 0 to 15. We use its 4 bits as 2 different 2-bit numbers. So we have 0 to 3 there and 0 to 3 there, and we can use those as different things. Of course, we'll take a look at some usages as well for these blocks here. So what we might want to do now is actually to allow you to change which side it's facing. We want to be able to do something at least. We'll add the color part later on. Okay, on block activated like that, and here we have a ton of things. I'm just going to fill these up. So we have the well, we have the X, we have the Y, we have the C, we have the player, we have the side. We're going to use that one. Hit X, hit Y, and hit C like that. Right, okay, so what do I want to do here? Well, I'm just going to clean this mess up a bit. I want them in the same line. There we go. Okay, so what's the drill here? Well, first of all, we do not want to do anything if you right-click on the top or the bottom. If you click on the side, on any of the other sides, the 4 sides there, then I want that side that you clicked on to be the active one. So you right-click on it, and that's going to change its rotation. Seems like a good idea, right? So to do so, I'll make sure that the side here is greater than or equals to 2. So that means that it's not 0 nor is it 1, because 0 is the bottom and 1 is the top. That's not going to be valid. And if that's the case, then we want, well, if it is the top or the bottom, then we want to return false here. We didn't do anything special here. Otherwise, we want to return true, like so. But we actually only want to do anything for real on the server side, so then we can do not world.isRemote there. But we still wanted to return true to tell the client that, alright, we should sort of do something here. The server is actually going to take care of that for us. Okay, so what do we want to do? Well, we want to modify the the side here that we have in these 2 bits depending on the side that we clicked on. So we want to set the current side to be this side. How do we do that? Well, first of all, we might want to get the current metadata. That's what we had so far. Well.get block metadata like that. X, Y, and Z like so. And then we can start modifying that. When we have done the modification and are done with that, then we can do world.set block metadata with notify X, Y, C, and then the meta, and finally a 3 there for the notification flag. And what this is going to do is we get the metadata, we do some changes in between here, and then finally set it again. It's not enough to modify this variable, that's not the metadata of the actual block. So get it, modify it, and then set it again. So how do we want to modify it? Well, what we want to do is basically 2 steps. We want to remove the old side and add a new side. And we've done these things before in previous lectures, even though we have used different values than sides of blocks, obviously. So what we want to do is meta, and then we use this trick here, oops, not that trick, that's something else, and equals to like that, and then we use the opposite of the mask here, so 0b1100. So that's the same mask there that I used up there when we actually worked with the side. So we invert that and then do a AND with the data itself, and therefore what we will get is, well, everything we had before but the side. So the side has been removed like so. And the next part is of course to add this side to this by using the OR here. But we need to do 2 things. First of all, we need to subtract it by 2. Remember, we do it subtract it by 2 here, and therefore we need to subtract the side by 2 here as well. So when we store it, we subtract it by 2, and what we compare it with, we should also subtract by 2. Why do we do this? Well, we only have 2 bits, so there's no reason to save it using 3 bits, just because, well, we want to save it as 2, 3, 4, or 5. We can instead just save it as 0, 1, 2, or 3, and if you just subtract it by 2 on both ends, it doesn't matter. We don't care about, well, the one side to be 3 and the other side to be 3. We don't care about one side being 4 and the other side being 4. We just care if they are the same. And therefore, if we subtract it by 2 here and subtract it by 2 here, that means that we're going to be able to store a 0, 1, 2, or 3, which means that 2 bits are enough, and that's perfect because we just have 2 bits to work with. Remember, in the metadata we can only store 4 bits in total. So that's the first thing. And another thing is to move them up 2 bits because we want to store them up there, not at the bottom right there. So subtract it by 2 and then move it up 2 bits like so. And that's pretty much it actually. So now if we right click and we right click aside, then what's going to happen is that we get the metadata, we remove the old side from the metadata, we add a new side to the metadata, and then we save it again like that. And that's actually everything for now here. Let's make sure that we can actually run this code. So we're missing a few things. We are obviously not adding the block here, so I'm just going to add it into blocks. So public static block color, and then I'm going to add it here. Color equals new block color, block info dot color ID. Game registry, so then it's time to register the block, and I want to use that one, so we use color and then we use a key here, so block info dot color key like that. And finally we might want to add a name as well, registry dot add name color block info dot color name like that. Oh, well, we need to do one last thing actually. We need to make sure to actually add this thing to the configuration handler, otherwise we won't use that default ID and everything will go wrong. Everything will actually crash and we'll run out of memory. Color ID here, and what we want to do is just config.getBlock. That's the one I want to use actually. Block info dot color key there again, and here we have the default value, block info dot color default, finally get int like so. So what we have is just a simple block, but we're using bit operators, so we can use these 4 bits of the metadata for 2 different values. We're using one for the color and one for the side there, and then we modify it like so. So when you click on a side, it's going to change to that side. Let's take a look in the game. There you go. So obviously we won't be able to change color yet. We can change the side, but not the color. There's no code here for changing that yet, but we'll take a look on that very soon. So first of all, let's head over here, grab the color deployer. So in the end, it's going to be deploy colors of some sort. And if we go around here, we can see, alright, that one has the front icon there. It's not too much of a difference. It's just a gray border in there, or well, a gray square inside the border rather. And then if I right click there, look, it's moving like that. Just because, well, we changed that when we click. But it's also keeping the white color, so it's not changing that to like red or green or whatnot. But we'll see a better example of that when we can actually change the color. Now we can only change the side like that. And we're using 2 bits for that, so we have 2 bits spare for the actual color. And we can't change it to the top one. So I'm trying to click there, nothing happens. There we go. Okay, so how do we want to change the color? Well, we could do that like, alright, shift click on it and you change the color instead, but that's boring. So what I'm going to do is add an item for it, and we're going to see more bit operators in there when we store data for that one. So let me just create an item here. Here we go. Class. Okay, what should I call this? Well, I'm going to call it item color charger. This one is going to charge the colors for the blocks, so I'm going to call it color charger like that. And what we want to do is extends item like that, and you know, we'll see a bit wise operators very soon here. Item color charger int ID. There you go. Oops. Okay, super ID here, and well, then it's just a matter of adding some boring thing here. So set creative tab, and what I want to do is, well, the misc one is totally fine. Tab miscellaneous, there we go. Then maybe set the subtypes to be true. Set has subtypes true. What's going on here? Alright, I haven't imported item, that's why it's complaining. And then set max stack size like so, set that to 1. Okay, so I'm going to set the unlocalized name later on. But what do I want to do with this item? Well, I don't want just to have different types and then set that to different colors of the block. But what I want to do is make it a bit more advanced. So this is the plan. I want to have an item that have sort of 4 different color meters. One for white, one for red, one for green, and one for blue. So what we're going to have is how many uses do we have left to use this for white? How many uses do we have left for this to use on red, and so on. And all of these are going to start at 7. So we have 7 uses of all of these things. And then when we have used up all the charges in all the different colors, then I want the item to break, and then we'll have to get a new one. Okay, is that it? Well, we also need to define which color to use when we right click. I want to do so when you right click this item on the block, then you change that block to the current color, but therefore we'll also have to save the current color of this item, and of course therefore we'll have to store the current color and the 4 different meters of how many uses we have left, which all is going to start at 7 and then decrease all the way to 0, and when they are at 0 we won't be able to use that color anymore. Sounds like a plan? Yeah, I do believe that's a good plan. Okay, so public, here we go, int get active color. So to start with, I'm going to just write some methods here that is going to help us along the way. So I want to get the active color here, but just getting it like this wouldn't make any sense because I wouldn't be able to base that on any information. So what I want to do is send along the damage value. So basically, if I send this method a damage value, then it's going to return which of the colors are the active one. So what I'm going to get, well, want to get at least, it's 0, 1, 2, or 3, depending on which of these 4 colors, which is the active one. And that's fairly simple. I can just define it like this, for instance. Return damage, and 0b11, for instance. And that's obviously going to be the very first 2 bits, or well, the 2 least significant bits like that. We need to save it somewhere, and since we have 0, 1, 2, and 3 as the values, we can store that in 2 bits. So I'm just going to use these 2 bits for that value there. So that's the first thing. The other method that I also need in here is get uses for color. So I want to know how many uses we have left for a specific color. So if we give it, for instance, color 2, then we want to see, alright, how many uses do we have left? Do we have 7 left? Do we have 5 left? Or whatnot. And therefore we might want to get the damage, so we can actually get information from anywhere, and then we want to get which color to use. And here it gets a bit more advanced. How should we store this? Well, these two are already occupied for the current color, so we can't use them. And I want to store a value between 0 and 7 for each of these colors, right? And 0 to 7, well, 7, that is going to occupy 3 bits, nothing more than 3 bits. So we'll never exceed 3 bits, so that's fine. So 3 bits per color. That means that we'll have to have 12 bits in total, and we have 2 bits for this one, so that's 12 plus 2, that's 14 bits, and that's actually totally fine. In the damage value we can store 15 bits, so that's a short, but we can't use the signed bit there. It's set up in a weird way, so we can't actually use that bit there. So we have 15 bits to work with. I'm going to use 14 of those, and that's going to work pretty good, I believe. So what do we want to do? Well, I think since we have these two first there as the very first bits, then we can just do these as one color, these 3 next ones as one color, these 3 as one color, and these 3 as one color, and well, like that. That seems to make sense. It would be weird to just mix them up. So just put them next to each other, and then we of course have the active color right there at the bottom. So how do we do this? Well, first of all, we need to create a proper mask, right? So 0B11100. That seems like a good start, right? We have the zeros here to, well, not get these bits through, so we don't want to get the value about the active color. That hasn't anything to do with the uses. And then we use 3 bits here to define the 3 bits for this specific color. However, this is just going to be the case for one of the colors, right? Yeah, that's exactly the case. So what we want to do is move this. We want to shift this to the left, so we move it up to the other colors if we have a color there. And what I want to do is simply do color, but that's not enough, right? If I have color 1, then I'm going to move it 1 bit to the left, and that's not enough. I want to move it 3 bits to the left because we have 3 bits here. So obviously the next bits we have come 3 bits after these 3 bits, because we have sequences of 3 bits. And therefore it's fairly simple actually. Just multiply the color by 3. Okay, this is our mask. And what do we do with the mask? Well, we just do damage, and then we do an AND there together with the mask. There's our uses. But of course we need to move them back down, otherwise we'll get, for instance, like 20, I don't know, 40 as our uses, and that's not the case. We want them to be their proper values. So therefore we want to move them down again. And we can just do color times 3, like we moved them up. Or can we do that, really? Well, that's going to result in something like that, but that's also wrong. So we want to move it down 2 bits further, and we can do so by just add 2 there, like so. And then we just return this in the end, like so. This is a possible solution. You could do it in other ways. For instance, we could remove those 2 bits and add that plus 2 here as well. So now we have the same part there and the same part there. But if we want to do, we could have like I just had, so we remove that and add the zeros there. So that's in a better way maybe going to indicate that we have those empty there. But if we have plus 2 here, we'll see that both the moving up part and the moving down part is going to be the exact same. So that's just a matter of taste, I guess. It's going to do the same in the end anyways. Right, so now we can use get uses for color and get active color to be able to do things properly. And what I want to do is add a description. It's very nice to have a description because then we can see what's going on. We have seen descriptions before to items, and we just have to override add information here. And what we get is the item stack we're working with. We get the player that is currently using this. We get the list that we want to add information to, and also a use extra info boolean here. So if you hit F3H to get some debug information in Minecraft, in vanilla Minecraft, then this boolean is going to be true. So if we want to add some extra information to this item, if that happens, then we can do so with that boolean value there. Okay, so what information should we add? Well, it might make sense to add which is currently active color and how many charges do we have left of all the different colors. I think that makes sense. But, well, just saying color 0 and color 1 and so on, that won't really help us too much. So maybe we actually want all the different colors. And that brings me to item info here. I'm going to add all that information in here together with the ID for this item and all of those things, like the unlocalized name and things like that. Here we go. Okay, so what do I have? Well, first of all, I have the charger's ID. I have its key here, so it's the color charger. Its default value, like before. We have the unlocalized name, the localized name, its texture prefix. Then we have a lot of colors here, and finally we have a lot of color tags. More to these color tags later on. We can ignore them for now. We'll take a close look at them a bit later. But what I'm going to use are these colors, but I also want to use this unlocalized name to start with, so we can just set it here. That was the part I skipped previously. So item info dot charger unlocalized name, like that. Okay, yes, side note there. Okay, so what do we want to do? Well, first of all, we might want to add the active state, right? Like I was talking about. So list dot add active color, like so. And then what we can do is simply add item info dot charger colors, like that, and then we need to refer to the correct index. How do we get the correct index? Well, we can use this get active color. That's going to give us a 0, 1, 2, or 3. That's exactly what we want. We need to give it a damage value, however. Where do we get that from? Well, of course, from the item stack that we have here. That's the item stack we want to get information about. So, yes, the brackets there. Then this get active color, and then we do stack dot get item damage, like that. So, well, that's fairly simple. We just get the active color, and to do so we need the item damage, so this get active color can use its bit operators to grab the 2 lowest bits. Of course we can do that right away here, but that's just silly. We have a method giving that for us, and then it's just going to grab the text at that specific index in this array here. So we get, for instance, white, maybe red, green, you know, things like that. And when we have that, it might make sense to actually loop through it all and get well, how many uses left we have of each color. And we can simply do so by looping through the charger.colors, so the length of those, like that. Okay, so what do we want to do here? Well, we can just grab the uses. It's fairly complex how we grab the uses, right? But we've already done that here, so there's no reason to define that any more time. So what we do is, of course, we move a mask up depending on the color, and then we apply that to the damage there, then we move it back down. We can add a parenthesis there to see it better what's going on. Then we move everything back down like so, and then we return that value. So fairly complex, but still, if you just take it step by step, it should be fairly easy to understand anyways. So what we want to do here is simply get uses for color. And what is the item damage? Well, we get that from the stack. Stack.get item damage. And which color should we get? Like, we want to get information about the color. How many uses do we have left? Well, of course we use I here. So that's our current color. We loop through here. 0, 1, 2, and 3. So we want to get them one by one. How many uses do we have for color 0, color 1, color 2, and color 3? We define the color there. Nice. And the next part is, of course, to add it to this list. But it's ridiculous to add all the values, so what I'm going to do is just say, alright, if we have more than 0 users left, then we add it. So if you're out of users of something, it's not going to be in the list of color charges that we do have. Lists, not lists, list.add, and then it's just a matter of doing something like users left of, like that, and then we do item info dot charger colors. Where is it? There you go. Refer to the index I there, and then finally add the uses, like so. That's pretty much it, right? So we add the active color, and we get that from the item damage by using get active color method, like so. Then we loop through all the colors and get the uses, and if we have any uses left, then we add that as a line in the description, like that. Fairly straightforward. Are we done now to test it? Well, of course not. We need to create the items, so let's do that. So I'm just going to head over into items here and create it here. Public static item. Well, charger is probably a better name. So charger. Charger equals new item color charger. Item info dot not droid charger ID. Like that, and then finally just add a name here. Language registry dot add name and charger, and here we go with the item info dot charger name. We must not forget the config handler. We need to add it here as well. So item info dot charger, where is it? Charger ID. There you go. Config dot get item. So just to get the item here with the current key and the well, the default value, basically. So that's the key and item info dot charger default. There you go, and then get the integer and subtract it by 256. Are we done now? No, not really. So what I have now sorry about that. So what I have left now is one little trick here. What I want to do when we craft these things, we obviously want to have full charges. Well, that's exactly what I want, at least. Maybe you want to force the user to refill it, so on. But what I'm going to do is, when you craft this, then you're going to get full charges, and then when you use it, those are going to deplete, and if you deplete all the charges, then the item is going to break and you'll have to make a new one. However, we might want to add it to the creative tabs as well. I'm never going to add a recipe to this because this is obviously just an example, and therefore I'm going to refer to the creative tabs and so on. But if we do so, then in the creative tabs, we will have the metadata, well, the damage value, sorry, it's damage values for items, that will be set to 0 because that's the default one. And if we have it as 0, then we will not have any uses left of any kind, just because, you know, we get the bits at those positions, but if everything is 0, then we have 0 uses of everything. So that's not good. So what I want to do is do a little trick here. We've seen this method before, but we use it differently. ID, tab, and list. Okay, so we've used get sub-items before to define, like, alright, we have 4 different types of this item, and what we want to do is, you know, add all of those to the creative window. But what we can do instead is the following. We can do list.add, and just add one item. We can totally do that. We don't have to add multiple items. And I'm going to use this to just add the normal item like so, but I'm going to give it a damage value, which is going to be the default one, the ones you get when you would craft. So when we made a crafting recipe, we would just do the same item stack as we do here. So what would the default one be? What would be the default value? Well, what we want to have here is 111, that's for the one of the colors, for the one with the highest ID actually, because that is moved the furthest to the left. So that's color 3. 111, so that's 7 charges for color 2. 111, that's 7 charges for color 1. 111, that's 7 charges for color 0. And then 0, 0, that means that we're going to start at color 0 there. And because I'm added like this, then this is the item that we're going to find in the creative tabs when we look for it in miscellaneous, like so. So that's pretty much it. Let's take a look and see how it goes. There we go. If we can load this up. Right, there we go. And in miscellaneous, we should find that one. No texture yet, but we're going to have that in a second. And if I take a look here, we have the active color white, uses left of white 7, 7, 7, 7. So it seems to be working. The item we got here does not have 0 as its damage value, sorry about that. So if we take a look, the damage value here is going to be 16,380. That doesn't really say as much, because we're working with it with bits and in binary there, so that will obviously be the value we had, this value here, or well, it should be at least, because that was what we set it to, but it's tricky to see that that's actually the case. But the value we have is 16,380, like so. And the information seems to be correct. But to be able to check that better, what I'm going to do now is add some functionality to it. What I want to add is to allow us to change which the current color is. And to do so, what I'm going to do is tell the user, if you shift click on the ground, then I want to change the color, the active color. I think that's a decent way of doing it. You can of course do it in other ways as well, like alright, you clicked on a specific key on your keyboard, then change that and so on. But I think shift clicking on the ground is good enough for what I'm going to do. Okay. So first of all, what I want to check is the following: if not world.isRemote, and if it's not, then we want to return false, like so. Oh, well, actually, let's do it like this. Let's just return false here if we manage to reach the end of that, and then if we don't reach the end of that, then I can just return true somewhere else. If I don't want it to reach the end, rather. Okay. If player.sneaking. So I said, well, if it's shift clicking, then we should change the type. Okay, that seems like a good idea, I guess. And if that's the case, then we want to return true, which means that the player actually did something here. But that's of course not enough. We actually need to do the things we're planning to. And how do we do that? Well, of course, with bit operators. What do we want to do? Well, we want to get the color, increase it by 1, and then set it again. So the two steps are fairly simple to guess. Damage equals stack dot get item damage, so we get the item damage from the item, and then we also in the end set it back again, set item damage, just like we did with the metadata, but now we're working with the damage value where we can have 15 bits instead of just 4. So what do we want to do here? Well, we can do it in a few different ways. What we could do would be to grab the active color, and then we could increase that by 1, remove the old color, and set a new color. But when we increased it by 1, we would need to make sure that we didn't reached 4, so we would have to use mod 4 and things like that. That would be a total possible way. I'm just going to do a little shortcut here. Next color equals damage plus 1 and 0b11. That's going to be the next color. Why? Well, the only reason why it works like this, why I can do it, is because I store the color as the 2 least significant bits. Like so, and what I'm doing here is just increasing the damage value by 1. I'm not going to store that. I'm not going to store that increment somewhere. I'm just going to do that here and then grab the 2 least significant bits. What that means is basically that if I have something like 0, 1, then that's going to be put to 0 or 1, 0 there, and then we're going to grab those 2. However, if we already have 1, 1 and increase it by 1, what we get is 1, 0, 0, like so, and therefore what we do when we grab it is that we only get these 2, which is 0. And that's exactly what we want to. If we had the color 3, then the next one is supposed to be 0. We want to loop through. Like that. Okay. So now we have the next color, a bit of a, well, clever way of getting it like that, but of course we could just get the active color, increase it by 1, take mod 4, and then add it normally. But now we got the next color like so. Remove the old color. We still have to do that. That's the old trick. And then we use the. I don't know why I typed that one. There you go. So we want to do that with the correct mask, which is supposed to be that thing. So 0b11. Yes, because that's where we store the well, the color, the current color, and then we just do damage or equals to next color, and we don't have to move this color up or down or anywhere, just because we're just using these 2 lowest bits. So if we have 0, 1, 2, or 3, they are going to be placed properly where they are supposed to be. Let's take a look. Here we go. And now if we take a look, we have the white color as the active one, as you can see there on the top row. If I shift click like so and right click the ground, we will have the red as the active color. We can see that on the top line like so. Then we can do it so, and we get the green one, we get the blue one, and the next time I do so, it should loop back to white, and it does that like so. Perfect. So what we will see later on is that we're going to give this some aesthetic, well, some aesthetics as well. We have no texture there, so also I want that to change depending on the active color, and we'll also see that we're going to use the uses to color these blocks, but that's going to be after the break. So now we have reached the break. After 50 minutes we'll be back and take a look at that, so I'll see you then.